Hello, I am Kirk Wallach.
I'm James Storica.
I'm Brian Pachano.
And I'm Eric Donch, and we are working on My Conservation Life, sponsored by the Second Park Zoo. So, going to the zoo used to mean a family trip to go see all the animals in their mock habitats, and perhaps making donations to foster animals. Most people overlook the projects going on outside of the zoo, or donate and forget about it immediately. For the future of zoos, such as the Seneca Park Zoo, there's going to be a movement from zoos functioning as a place to see animals in cages to a hotspot for global conservation efforts for Mother Earth. These projects are typically tracked through cumbersome methods of storing information, such as spreadsheets and written documents. Making use of digital storage will greatly help refine this process, as well as assist in keeping transparency for the public. The Seneca Park Zoo has recently started a reforestation project in Madagascar, and that project will be the first to use our system. We will be tracking assets, which in this case would be trees, actions, which should be the work done to prepare and plant these trees, as well as keep an eye on the impact overall, which may be a number of things, such as replenishing wildlife and restoring rainforests. Tom, a sponsor from the Seneca Park Zoo, has shown us what it's like in Madagascar. In these pictures, you can see the problems they face, the technologies which are being developed in order to make conservation efforts more affordable and efficient, as well as engage zoo-goers in conservation, and you can see the current state of Madagascar as a result of farming-driven deforestation. Madagascar, being a very biodiverse part of our planet, will be a perfect use case for our system. The use of new technologies are giving conservationists a type of advantage that has not been possible before. So, why are we here? We're creating a cloud solution for Seneca Park Zoo, as well as other zoos, to collaborate, record, and track everything within their conservation projects. We want to make it easy for donors, scientists, and even the general public to take a peek into conservation projects and see where all the donations end up going. A few other things we plan on having is the ability to track changes over time in our data, also known as temporal data storage, so that one day we can have a graph of the reforestation efforts over the course of multiple years. So, as you can see over there, we have plenty of different users who are going to have a different view of the database, which will be geared toward their specific needs. Field participants, visitors, zoo staff, researchers, explorers, and donors will each have different interests pertaining to the system, so each of these users will have a unique interface in which they will interact with the system. Donors, as an example, will be able to see a collected list of each of their donations. They will be able to see the impact of other donors in their areas, and they will also be able to view more conservation efforts that they may be interested in.
Yeah, so to try to understand and untangle these user types and interfaces that they'll belong to, our group as a whole wanted to focus on these 4 different user types to try to narrow down our scope. So these are the donor, the zoo staff, field participants, and other zoos. Donors is your everyday person that visits zoos. We can collect donations through their front gates for a small donation to a conservation project. And there's other ways, such as going to the gift shop and buying a pre-made package that supports different conservation projects as well. The zoo staff is the administrative side of My Conservation Life. This is where different projects will be defined, the domains will be laid out, and the schema defined for each project. So for the Madagascar project, an example, this is where trees will be defined and having a plant date, a nursery that they grew up on, maybe who planted it. For field participants, this is we're going to be talking about the middleman between zoo staffs and the ground workers who actually plant the trees. They will go and collect information from those workers and input it into My Conservation Life under that project that has been defined by the zoo staff. And other zoos, this isn't particularly a user type, but we need to keep it in mind because each zoo that adopts this My Conservation Life will be able to collaborate with other zoos that have also adopted it. So the Madagascar project, they'll be reforesting different hectares of Madagascar, and say a new zoo wants to come in and study the new flora that pops up or returns. The donor at the end could go into their donations of trees, and through a little bit of digging, they could come up across other projects that are going around the area. So to handle all this, we need a database that can handle geospatial data, temporal data, data provenance, and unstructured data. Geospatial data is how you relate information and data to different parts of the globe. They can be defined as a point, a radius around a point, an area such as a forest. Temporal data, that's how it's kind of like time stamping an asset as it reaches its life cycle. When the tree is planted to, checking up on the tree when it's in a forest. Data provenance, this is keeping a historically accurate record for each asset. And then unstructured data, because while we're starting off with the use case of Madagascar reforesting, we're not really sure the different types of new conservation projects that might spawn up and need to be defined in their own special ways. At the end, we'll need a product that is easily accessible by the public. This is going to be used by everyday people who go to the zoo, maybe people who are curious about their local zoo efforts. And every project's data needs to be able to be shared between each adopter. So we're focusing on that donor interface. The end user donor will be able to go through this and be able to track their donations as well as all the projects that their local zoo is doing. It consists of a homepage, a project page, donor homepage, and donation details page. The homepage, that's just a generic overview of what My Conservation Life is, maybe some highlighted projects here and there. The project page, this is individual projects details. It shows all the assets that belong to it and more information about the project. Donor homepage, when a donor logs in, they'll be able to see their lifetime of donations made to different projects. And then that donation detail page, when they want to look at more information about an individual donation that they've made, that's where they'll see all that information.
The technologies that we're using to build My Conservation Life are the Salesforce platform and a geospatial database. The Salesforce platform is used by conservation projects, including the Madagascar Reforesting Project, to provide a few important functions. It provides them record keeping, so they use Salesforce to keep track of their ecological assets and other project information. Salesforce provides workflow management for conservation projects to manage their conservation actions. And Salesforce also provides user management of the various people who work on conservation projects. So we're building a Salesforce community called My Conservation Life that conservation project sponsors can install within their Salesforce organization to provide our product. The next major component of My Conservation Life is a geospatial database. A geospatial database stores information about points on Earth and regions on Earth and allows our product to efficiently process this information. We use points to represent things like the locations of trees and the locations of sensors, which are part of the impact data we're going to show donors. We also use the region type to represent things like the location of a conservation project and areas within conservation projects, such as forests, and provide aerial images of the area where a conservation project is. That's part of the impact data. So in general, we're using our geospatial database to store conservation project information, ecological assets, and impact data. We selected our geospatial database technology through a process of research and setting up a prototype. We set up a prototype to verify that the database technology meets our technical requirements. The first database option that we considered is BigChainDB. It's a traditional database that's extended to have a blockchain component. The blockchain component is capable of proving that a donor made a particular ecological impact. Unfortunately, this database option development has stalled, so we had to consider the other options. We also looked at Google Earth Engine. Earth Engine is a great tool for analyzing spatial data. Unfortunately, it cannot handle real-time updates of data. which is something we want to do when, for example, a donor sponsors a tree. We want to provide immediate feedback within the donor interface to that donor. So next we looked at ArcGIS. It's a commercial product, but unfortunately it would impose the requirement on each organization that implements our project to pay for the ArcGIS product. So we also considered a free alternative that is PostGIS. PostGIS is a spatial extension of the PostgreSQL database. And it's free, open source, and most importantly, it's available as a service on the Heroku cloud. We take advantage of this because Heroku provides a feature called Heroku Connect, which used to integrate Salesforce and our spatial database. The architecture of our product looks like this. We have the Salesforce part, in which a conservation project organization installs our Salesforce community. Once they install our Salesforce community, they'll have their own website where the public can use, for example, our donor interface and other interfaces we're providing in the future. Salesforce will contain user information, and the spatial information is going to be inside of PostGIS. And we're going to use that information using the Heroku Connect technology. Next, we would like to talk about the process methodology which we used on our project.
So process methodology, the plan within the plan. This is how we got our work done. So I'm sure most of you are familiar with the Agile Scrum methodology. This is what we used. So I'm not going to explain what Agile Scrum is, since most of you do. Instead, I'll just go over some of the specifics of what we did. So the product backlog is where we kept our deliverables, the overarching points we were trying to reach. And in the sprint backlog, we kept the more individualized, the smaller tasks that we could accomplish during a single sprint. So our sprints were just 1 week long. And during the sprint, we had the sprint planning, the sprint retrospective, and the sprint review. So the planning and the review were during our Wednesday meetings, and the retrospective was during our Monday meetings. Usually, Agile has a daily scrum as a part of the sprint process, or a daily stand-up as a part of the sprint process. We decided to opt out of that and instead just meet on Mondays and Wednesdays due to our conflicting school schedules. So that is how we used Agile Scrum, but how we kept track of all that data was through Trello. So Trello is a flexible list management tool. I think some of you have used this before. And it allowed us to keep track of all the different tasks we were doing and what was going on with them. So on the far left is our product backlog column, where we had those deliverables. The ones at the top are the ones with the highest priority, and the ones at the bottom are the ones with the lowest priority. So we would get to the ones at the top first. The next two columns are the tasks and the sprint backlog. That's where we would generate the new tasks and the new actions. During our sprint planning, we would come up with new tasks that needed to get done. If we thought we could get to them during that sprint, we would put them in the sprint backlog. And then any tasks that we didn't think we were going to get to during that sprint would just get left in the task so that we don't forget them. The individual boxes you see up there can get picked up and moved to different columns. So the general progression is that they start on the left and move to the right. So once we started the task, it goes into that doing column right in the middle. And then once it's completed, it goes into its respective sprint column. And as you can see on the far end, the sprint columns just kind of build up. That way we still keep record of all of the work that we've done. So over this last semester, some things went well and other things went not as well. So what we have here is the good, the bad, and the ugly. So what was good was, I think, that we worked really well together as a team. We had a process that really resonated with all of us. In particular, I think the week-long sprints was something that worked well for us because it ensured that every week we made at least some amount of progress, even when we had a lot of other schoolwork to catch up with. So then the bad, I think, is that we had a pretty slow start with this project. When it was first introduced, it was pretty overwhelming. It was large scope and just a lot of information to take in. And so we spent a lot of time figuring out what the project was, but then also figuring out how we wanted to tackle this project and what we were going to take care of first. At this point, the ball's gotten rolling. We're feeling much better about the project, but that was definitely something that could have been better. And then in the ugly, what I have there is a picture of blockchain. So in our initial project description, blockchain was a technology that was featured as being able to take care of some of the requirements we needed, mainly maintaining data integrity. And so this was something we spent a lot of time researching and learning about. And just about 4 weeks ago, or actually, so we had mentioned the Big Chain database as one of the databases we were looking into, and this was a database that provided a lot of those blockchain features that we needed. And so that was something we had looked into for quite some time. But then just about 4 weeks ago, we had actually scrapped blockchain completely. And so it feels a bit like we may have wasted a lot of time due to spending so much on blockchain and then just letting go of it. So that's the ugly. But that was last semester, so what's going to be going on next semester? So these are our future increments, what we plan to do. So right away, we're going to wrap up things with the donor interface that we were talking about. We're going to fine-tune those features, and we're going to make it look a lot nicer. So that's our right away plan. After that, we're going to go back to the back end, and we're going to get the distributed system fleshed out. So right now, we're using one database and one server representing the Seneca Park Zoo. But it's important that down the road, other zoos will be able to run their servers, connect, and share their data. So it's during that increment that we'll flesh that out and get that all working. We have the architecture in place. We've been thinking about it, but it's going to be after the donor interface that we actually implement it. After that is the other interfaces. So the donor interface is our high priority interface, but hopefully if things go well, we'll be able to start working on some of the lower priority interfaces that we've talked about. But that's somewhat in the air still as we progress, because the increment right after it is extremely important, because we have already made plans at this point to pass off the project to another senior project team. And so as this project closes, we're going to need to go through the documentation that we have, organize it, and make the next steps very clear so that the next group of students is able to easily understand our project and take off from where we left off. All right, thank you. Do you have any questions?
You mentioned that you're going to be working on other interfaces. Do those interfaces do those also coincide with the acquisition of the other type of users
So
I'll take it. Right now we have that donor interface, but these user types that we're focusing on, that donor interface is really only for the donors. We're going to be creating mock data. Let me back up. So the zoo staff is what defines a project and how it's going to be, and what's within a project. That's just kind of going to be mock data for now, as the donor interface is being fleshed out. But other interfaces could be a way to, configure new projects through like a user-friendly interface instead of having to know back-end knowledge. Field participants, they're going to be inputting data into the My Conservation Life. And right now, with the donor interface, there's no way to input data. So that could be another interface that also is elaborated on. Yeah.
Go ahead.
Was finding out that blockchain wasn't suitable, was that a risk that you were prepared for and you had seen coming?
Well, as we were researching blockchain, a lot of the research we had done was on the cons of it and the reasons that we thought it might be a problem moving forward. And so we continued throughout our development to look at what the problems might be, and it took a lot of time to eventually figure out that, okay, this is the con that is too much. We can't keep using this.
Yeah, we had our doubts, but then when we found Big Chain, it was like a glimmer of hope, and we really liked Big Chain, but then we found out that there were no further blog posts from them, no updates since like October of last year. So that was just too much of a risk to keep going that direction, so we just ended up scrapping it.
And another thing from our retro we had just the other day, making cutoff points for different features that we're exploring could have been a great mitigation strategy. because we wouldn't have to run away and get lost in it, you know.
What was the reasoning behind 1 week sprints compared to longer?
Well, I definitely pushed the 1 week sprints. I preferred it, and I think my reasoning on that is due to a tendency to procrastinate. So if we had 2 week sprints, it would just be every 2 weeks, the last 3 days, I do all the things. So 1 week sprints just ensures that I do all the things every week.
Yeah, and plus when we were doing all the research, it was helpful to have that in 1 week sprints so that we would be, looking into a lot more frequently. So we just sort of rolled with that going on.
In the front.
Related to the 1 week sprints, I know kind of the reason we didn't do 1 week sprints was because some weeks it could be that not many people have, not enough people have enough time to get stuff done, especially since we're kind of in similar schedules of classes. Did you guys run into those issues where you didn't get as much done?
Yeah, definitely we had carryover some sprints. We kind of just flew with it though, and we copied the cards back into our backlog. And yeah, tests, life happen, so. I think we've been pretty good though, sticking to what we predicted. It's only a couple times that we just carried everything over.
Yeah, we actually have like a metric for overshoot, so we made sure that we were within our predictions for most weeks.
How do you guys plan on implementing testing?
The basis so far, and for that, we had a couple different proposed schemas, and so we implemented each of them, created a lot of data, ran some queries, and just recorded the times it took to do all these different actions.
One of the most important parts of this project is going to have data just quickly accessible. So most of our testing has been in the means of, how many requests can you send to this sort of database in a short period of time, and just, just responsiveness.
And I know we have a pretty segmented project. We have our interface on Salesforce, and we have a back end, and we're going to have like a middle manager that handles the distributed system. That stuff we'll still have to figure out. How Salesforce has unit tests, we don't know. But yeah.
What's that?
Hello everyone, we are Team TBA team name. We're working with Constellation Brands this semester and next, and we're working on a web crawler with them. I'm John.
I'm Roger.
I'm Ben.
And I'm Corkid. So I'm gonna quickly go through the project overview here. So this is the problem statement that was given to us at the very beginning of the semester. So to expand on it, Constellation Brands, they're a B2B business, so they have to go through a distribution network to sell their product, so they don't really have a good way of getting that information that the end customers, how they're using their products. Are they drinking? Is it on tap? Is it are the wines by glass or by bottle? And stuff like that. Especially when we're talking about a lot of smaller, more independent liquor stores, bars, and restaurants. So because there's no avenue of no realistic avenue of sending that kind of data to Constellation brands. The solution was to build a web crawler to get that information if they have a website and that data is available. So that kind of data is really useful in sort of identifying trends. Maybe some beers, people are drinking it less, so maybe you can optimize your distribution network that way. So this is I'm going to go through the project overview. It's split into 3 parts. The core criteria, which is what sort of information we're looking for at those websites. Data acquisition, how we're going to pull that data, and stretch goals. Stuff that was maybe in the original project plan, but we don't know if we're going to get to or not. So with core criteria, here is the example table of a local tavern and their tap menu, basically. So it's got a lot of the information that we need, the name of the product, sort of the serve method, which is a draft, and the price. So specials are also useful information, but they're usually in a different part of the website and will have to be called separately. So with that data acquisition, this is a pretty big scope, considering that all these independent places have a lot of different formats, a lot of different ways of showing information. Some of it's through PDF, which may be just a picture or actual text. So for that, we will just be saving the PDF. We're not going to mess around with that too much. The main stuff is just HTML-based. What came out early was depth versus breadth crawling. There were 2 options that we could have done, which is either have a few very general-based crawlers that may be able to crawl many, many websites, but maybe not be able to get all the information possible, versus having more specialized crawlers that will be able to pull as close to 100% of the information that Constellation Brands needs. So we decided to do depth crawling, which will also help us in deciding acceptance criteria. So Constellation Brands also has existing data that they have on their customers, and of course, so we have to connect to that, whether through location or their unique identifiers and stuff like that. And of course, we'll be saving historical data to analyze trends, so we can see them by date, by location, by product, or product category. So stretch goals, these are what I was talking about. In the original project plan, there were some that were defined as bonus and some that weren't. We argued that we're probably not going to be able to get to these in the time frame. So that includes data visualization. Constellation Brands has access to Oculus VR headsets. So the potential of an AR, VR experience, maybe a data room for data visualization is a possibility. And also more generic reports through bar graphs, tables, and scatter plots. And also, if a customer does not have that data online, maybe an automated system that would send an email to request that data could be constructed.
Okay, so now I'm going to go over our process. We chose Scrum. So how that looks for us, we have bi-weekly meetings, 1 meeting with our sponsor and then 1 meeting with just the developers. We have 2-week sprints that allows us to tackle bigger stories while also having enough time to present to the customer. At the end of our sprints, we have demos, sprint planning, and then sprint reviews, so that shows where we are, where we're going, and how we can fix potential problems. For our backlog, we use Trello, and for subtasks, we use GitHub issues. We chose that because it allows us to GitHub issues is closer to the code, so that helps us. So some benefits of Scrum, it's good visibility for the stakeholder, and it also helps with delegation of tasks for developers, because it's a defined process. Some challenges we came into, so we can't do daily face-to-face meetings just because we're all in class, and that also means we can't do daily progress. So we have to kind of work when we can, asynchronously. And it was also difficult starting, so it was the storming phase, just finding how we can best fit this methodology for our project. So for our design and the technology, we use Scrapey as a scraping framework. We use Selenium as a web browser automation tool, and we use MySQL for storing data. For some techniques we use a bag of words. So when we scrape data from a website, we have to determine what information is relevant to us or not. So we have lists of words, and we'll compare the information we scrape to that list to determine how relevant it is. We also implement a strategy pattern because each website is different in how they store data. So we have to make a strategy for each website. So this is a flowchart of a scraping job. So first off, the job scheduler will get a list of locations from the database, and they'll hand that off to Scrapey, and then Scrapey will scrape the website for menu data, and then that menu data will get committed to the database, and then the process kind of repeats, except we're looking for drink data now from the menu. So the job scheduler finds the menus it wants to scrape from the database, and then it passes that off to Scrapey, and then Scrapey will extract the drink data from those menus and then commit it to the database. So this is our ERD. I'll go from right to left. So we have locations, and locations can be a part of change, so that's that relation on the right. And menus are essentially representative of what we scrape from a website, and joining drinks and website is menu drinks, which in menu drinks is the data that is mutable that we expect could change for each scrape. And then also at the top there, we have specials like sales for specific drinks.
So next I'll be getting into some of the metrics that we found to be valuable through the sprints that we've had so far. So the two that we found most valuable are velocity and then our issues that were generated per sprint. So those issues were tracked through GitHub issues, and that could be anything like a bug fix or refinement, stuff like that. So the first one I'll get into is velocity. I'm sure everyone sort of knows what velocity is. It's a main component of Scrum. So early on in the project, during Sprint 0, which is a week long, we all sat down, we sort of created a product backlog, and then as a team we played playing poker, and we assigned story points to each user story that we generated. So through each sprint we've kept track of how many user stories we've completed, and then we get the velocity by combining all the story points from those user stories. And one thing that we've found is that we've been able to be pretty consistent at the amount of user stories and story points that we complete on a week-to-week or a sprint-to-sprint basis. So this is just a chart of our 5 sprints that we've done so far. So each sprint is 2 weeks long. So at the beginning with Sprint 1, we obviously didn't have anything to gauge from, so we sort of made an educated guess as to how many story points we should be using. So we actually ended up picking a pretty solid number with 7. As you can see, it's about average as to what we did. So we felt that that was a good amount of work at the beginning, and we used that as a guideline for Sprint 2, Sprint 3, Sprint 4, and following. So with that, there is a little bit of variation in there, such as Sprint 4 being a little less, Sprint 5 being a little more. And that really just coincides with how much coursework we were receiving as a team from our other classes. So what we felt we could, at periods we felt we could get a little more done, or maybe we couldn't get as much done that week. So our next metric is our issues per sprint. So like we mentioned, we use Trello really as just a sprint backlog, but at the same time it was pretty high level for us. We didn't really go into detail with those user stories. However, with GitHub issues, we were able to really define some more detail, and we linked our GitHub to our Trello so that we could link those issues directly to our Trello user stories. So with that, tracking that allowed us to really see how many issues maybe we could expect on a sprint-to-sprint basis, and then it really allowed us as a team to spread out and really use each team member's effort equally among user stories, so that we weren't giving one of us a user story, but we could use maybe 3 of us on a user story when we assigned ourselves to individual issues. So, and then just a statistic at the bottom there, we've had 32 issues open through our first 5 sprints. And this is just a chart. You'll notice that right off the bat that Sprint 4 stands out. I'll get to that. So with Sprint 1 and 2, those sprints were primarily used for research purposes, if you want to say, or a large proportion. So Sprint 1, we started using our Scrapey library. That was so that we could scrape these websites. for data. And sprint 2 was pretty much our database research that we did. So we had a few research spikes in that sprint that we spent time on. And so we didn't have a ton of issues open during that period just because a lot of it was research based. And sprint 3 was really used for parsing beverage details from menu objects that we collected. So this was one of our biggest user stories point-wise. So that was the entirety of our sprint, and we broke that up into those 5 issues there. Sprint 4 is a little bit larger. That was when we were setting up our database, our ORM, and that we were creating all our database objects to be exported to the database. So we could break that up into pretty granular issues, such as creating a drink object, creating a menu object, creating stuff like that. And then Sprint 5 is what we're currently working on and finishing up tomorrow. That sprint there's not too many issues just because part of the sprint was work towards the presentation and just doing some small goals that we could get done beforehand.
So now I'm going to do a bit of a demo. So the starting point for the scrape is the location table, where we store all of the locations that we want to have scraped. The important thing to look at here is the URL and the strategy. But first, we use the URL to schedule menu finder spiders to find menus, which then will result in entries in the menu table, which have the menu URL that was found by the menu finder spider, and the scrape date, which this is where the date of the scrape is stored. It sort of represents a scrape that has happened. After this, the next spider that is scheduled is the menu scraper spider. It gathers all the URLs are gathered from the menu objects, and they are scheduled with the menu scraper spider, which will then result in first these menu drinks items, which relate the menu ID, which we saw before, and a drink ID, which I'll get to, and things that are not constant for every drink, like the price and the serve method and serve size. That drinks can be served in different sizes, obviously, so you don't want to relate that to the drink because you want to create less drink objects. Finally, we have the drinks table, which is where we keep the data about the drinks we've found. You query it to see if there's a matching name compared to the menu. And finally, a bit of reflection. Positives, we've been making good progress every sprint. Pretty consistent. We haven't had any sprints that have been a complete disaster. Slack communication has been very good for us, especially with our conflicting schedules, making it hard to meet. It's essential that we communicate well over Slack. There have been some negatives, though, that kind of have been highlighted more recently. We did not prioritize deploying the system very early, which has meant that we've sort of created more and more elaborate spiders, but as it's inevitable that we have to deploy it, and when I've started to try to do that, there have been a lot of issues. Not having an environment that is being deployed to has also prevented us from having sort of a common area to see mistakes that have been made or errors or issues. So you're only pointing out stuff locally that's on your computer. You don't have a common area to sort of see what is done. We spent a lot of time on spikes early on, especially in Sprint 2. And we also had a bit of hard time with these large stories that we didn't break down for other across team members. Instead of handing, what we did was hand each person a story, but a lot of those were sequential. So what ended up happening is you're waiting for someone else to do work, and then you get started, which caused some issues. Or in the case of one sprint,
you didn't break it down enough so that one person didn't really do that much during a sprint, and as much as they could, especially if they didn't have much to do, or much other classwork to do, say, at time. So things we're going to consider for R2. First, we're going to reflect on R1. I think we're going to sort of look back and see what things need to be improved immediately that we haven't covered for this presentation. We are definitely going to focus on fixing our deployment issues. It really is going to help resolve a lot of the issues that we're having right now that aren't necessarily even related to deployment. We're also, to ease handing over to our sponsor, I think we've talked about possibly asking to move it to the cloud. Our architecture, we have deviated from what we originally thought about, and it's kind of hard with the one VM we have. It's hard to sort of try new things, or you have to worry about like preserving it instead of just being able to get rid of it at any time. Additionally, configuring the database on your own is added more work than using a managed database system, which would probably save us time. Additionally, having separate environments would be nice to have, especially as we get something more deployable. Having a production environment will allow us to allow the sponsor to have something to work with that isn't something we're developing right now, and therefore it better see where we're at and better use the information more quickly as well. We're then going to sort of analyze the end goals that we had set before, see how they might be different from what we've learned over R1. We feel that definitely there's things that we could do. We have a better idea of what we can have at the end, and therefore we should sort of decide which one of those we want, and then use that to drive the backlog maintenance we need to do to actually deliver that product that we decide that we want to deliver. And time for questions. Go ahead.
You mentioned PDF saving. You didn't mention anything about analyzing a PDF. So what is the point of PDF saving in Illustrator?
So the point is to at least have the data available. So once, say, Constellation Brands says they want to look at menu data, but there's nothing concrete in those tables in the ERD, they can still at least look at the snapshot of the PDF.
And I think that's also partially a bit of a thing where we need to refine what we're making just a place to get data from just as an API, or is it something that's visual where people are actually looking at menus or pulling, or is it a place to pull menus onto other apps, or kind of like if there is a visual component to this, or if that's desired anytime soon, will kind of dictate how big of a priority that is.
Do you think plans on like text recognition for images, or is it mostly for by
I think pretty early on we decided against doing that.
Do you have any answer? I'm the Constellation Brand. We have a team working on that, like a couple technologies with that, so we told them to, put that towards the back of that. We do it with some other, we'll see our technology. Cool.
So I'm not sure if I missed it or not, but what are you guys using the menu data for?
We are just getting the menu data. The use of the menu data is up to them.
Okay.
I mean, it's
More
going.
insights, competitive analysis. So if we could spot the next New England style IP base before our competitors do, and we can start making those and acquire that company.
I kind of work in this a lot. There's a lot of other menu trends, I think it's called, which are kind of we have all the trends and regions and stuff. Are you competitive to them, or just like,
Could be, what I pay for it. There are other retail sites like Walmart, but .com, and people are straight to some of those retailers now.
Good.
So the two that I mentioned, so the first one was the velocity. So we use that. It's obviously not the best metric used that can be used to guide a sprint. That's some data that we had available early on, however, and so when we finished our sprint one, we actually felt like that amount of work that we had completed filled up that amount, like it filled up that 2-week sprint pretty well. So we went with 7 story points for the following week, and that turned out to be a really good guideline as well. So we pretty much use velocity primarily just as a guideline for estimating the next sprint.
Okay. Good evening, everybody. We're the KGCOE Embedded Data Collection System team. I'm Kimberly, and these are my teammates, Jack, Michael, and Peace. Okay. We'd like to start off the evening by briefly walking you through our agenda. So first, I'll be telling you a bit more about what our project entails, and then we'll launch into a quick demo. Next, we'll go through the methodology we use, which, as everyone else uses, it's Scrum, followed by an overview of our system's architecture and the tools we employed to create it. Then we'll discuss our reflections on what worked and what we think can be improved. And then finally, we'll state what we intend to accomplish at the start of the summer semester. So our new state-of-the-art data collection system, the Embedded Data Collection System, is designed to collect a variety of data from autonomous devices, such as this guy. That is the pneumatically powered robotic fish. And we'll be collecting data from him and along with the various drones and RC cars available all here at RIT. And then it's intended for use by our project sponsor, Kathleen Lamkin-Kennard, as well as her colleagues and her students. So the EDCS is designed to collect fluctuations in various conditions, such as pressure, temperature, and rate of acceleration. Other conditions include, but aren't limited to, gathering the results of any induced fail states, such as if we remove its battery supply, as well as the battery life and the position of the device. All of the collected data is going to be displayed in readable summaries on our website, and it will be easy to search through them by various means, such as by its associated experiment ID, between a specific interval of time, as well as by a certain condition, such as pressure, or a subset thereof, such as pressure plus temperature, and which will all be available through searchable metadata.
So the next thing we're going to do is we're going to hop right into a demo so that you guys can get a good idea of kind of where we're headed and what we're doing with this. And so this demo is going to show you one of the features that we have, which is the ability for users via our website to insert sample data and kind of mock being a device in the system. And so the first thing we're going to do is we're going to log in as a user that has elevated access. And then we're going to go over to our output data column tab here. I'm going to select a robotic fish as our device. From here, we're going to link our robotic fish to one of the experiments, and we'll choose the interim demo experiment here. And now we're going to select which type of output we're going to be putting our data in for. And we're going to actually add a new one, and this is going to be temperature, and we're going to say that the units for this are going to be degrees Celsius. So once we put this in here and save it, we'll see that it's selected for temperature. And then we're going to say our first data point is going to be 20 degrees Celsius. So we'll enter that in and save it. And then a little while later, we measure our temperature at 25, and we'll save that. And we're also going to add in a pressure data point. And we're going to say that our pressure was 2.4 psi. And so we'll save that. And so at this point, we have a little bit of data in our system in our mock experiment here. And so if we go to our experiments tab and select the experiment we selected the output data to, and if we open up the file that we download from here, we can see that our data is stored. We have our 20 degrees Celsius, 25 degrees Celsius, and our 2.4 psi, and these are all stored under the robotic fish as the device.
So next we're going to talk about the methodology that we chose, and like everybody else, we chose Scrum. And we chose Scrum simply because of its simplicity and familiarity with it. So how did we use Scrum? We decided to use 3-week sprints and have 3 stand-ups per sprint. So we chose 3-week sprints mostly because of timing. We just wanted to be able to get a good amount of work done to be able to show our sponsor where we're at in the project. And we chose 3 stand-ups mostly because of availability and how best we could meet each other during the semester. We also decided to use Scrum because of its the ease of mitigating uncertainty and other risks that involved transparency. So we were able to actually mitigate those risks by changing things up whenever we needed to change something in our backlog. If the sponsor if the sponsor decided that something was needed to be less priority than others, we could do that easily as well. So this also made it simple to produce a basic prototype that she can see and know where we at with the project. So the way we use Scrum, we had our product backlog and sprint backlogs, just like everybody else must have had. So we created our stories based on the requirements that we gathered at the beginning. Since this project was actually kind of ambiguous at the beginning, we were able to flesh it out as much as we possibly could, and then we checked our stories for validity with our sponsor and made sure that the stories that we produced would adequately cover exactly what she wanted us to make for her. So we also prioritized these stories with our sponsor. So going into our sprints, we reprioritized these stories and based on our sponsor needs, and then we pulled them into our new sprints based on our velocity that we had in previous sprints, and occasionally we sometimes broke down our sprints, our story points. So the metrics that we covered, like I mentioned, were velocity, which is just roughly how much work we got done per sprint, and we used our burn down charts to be able to figure out what our velocity was, and we also tracked hours that we put in to kind of make sure everyone is putting around what they needed to per sprint. So this is an example of our first burn, or this is our first burn down chart. We pulled in our stories based on commitment because we didn't have any prior data concerning sprints. And so for our next sprint, we also kind of did that based on commitment, but also based on our previous velocity. Even though we did increase the number because of carried over stories, and also we thought at this time we would get more familiar with the technologies and we would be able to accomplish more. However, that didn't happen. But going on to the next sprint, you can see that there's a huge jump in the number of story points that we were able to complete. This is our most recent burn down chart, and we seem to have done a lot more than we had planned for.
I'll lead you through a high-level view of our architecture now. As you can see, it's all centered around our API. All communication with our database goes through the API. Devices use it to upload data. Regular members of the KGCOE can use the website to either download raw data if they want it in JSON format, or upload their own sample data like you saw. They can also use the website, which will talk to our data visualization that can format it into nice summaries and graphs so that you can easily view it and understand it. An example of how our architecture changed was we originally envisioned the API as a way for the devices to put data in our database. Didn't think too much of it beyond that, but we realized we could reuse more code and keep things consistent if we made all communication to the database go through the API. So the users and the devices would be using, for instance, the same functions to upload data to it. A high-level view of our database schema. See just the table names here. We have an experiments table, which will contain a list of device outputs. These are readings like 5 degrees Celsius at 4 p.m. Also has any user inputs, which, as we mentioned earlier, we track induced failure states. A user input might say at 4:05 p.m., remove the battery. These experiments would be linked with associated devices, and as you can see, our devices experiments table actually links to the users table, because in our design, a device is simply a special type of user. I'll explain more on that later. And lastly, we have an output types table, which is useful for having that handy drop down so you can see degrees Celsius and pressure and whatnot. So one of the ways in which we refined our database schema as we were working on it, we originally had a table for devices as separate from users, but as we were doing the functionality, we realized that a database is just a user that has write-only access. When we realized that we didn't need a separate table for it, we could just code it as a user and make a new level of permissions that could only upload data to the database. One thing we were thankful for when making changes like these was that our product was not released yet. If we had to worry about preserving data as we were messing around with our database schema, it could have taken a lot longer, but thankfully we were able to change it freely as we wanted. Some of the tools that we used to implement this architecture and design, we used PostgreSQL as a database. It was sufficient for our needs, and I had previous experience with it, so I recommended it. We used Node.js for our API on the back end. Picked this simply because it was a simple tool to write an API for. Used Angular for our front end because it has good usability, useful for making a modern application. It's flexible and the right size for what we wanted to do. Also, Jack was familiar with it and recommended it to us. We're using Nginx to host the front end on a VM. That's our production PM. We picked that because it works well with Angular. We're using SOAP UI for back-end testing because Kimberly was familiar with it already. And we're using Jasmine for front-end testing as it's built in with Angular.
Okay. So, in an effort to apply the Scrum framework, we initially overpacked our stories. A quick example of this was that we ended up putting both back-end and front-end functionality and combining them into one story, rather than breaking them down into multiple stories that would have been much more manageable to complete given our sprint duration. In understanding this, we were able to move forward creating stories that better suited our sprint velocity, as was evidenced by the improvements shown in our final burndown chart. As mentioned by Peace before, we set the length of our sprint to be 3 weeks long to best suit our schedules. This worked out well for the semester as we gave ourselves more or less adequate time to just breathe, to catch our breath, and to be able to finish to finish our other coursework, excuse me. Lastly, looking back, we agreed that we should have incorporated sprint retrospectives at the end of each sprint. Sprint retrospectives would have presented a good opportunity to go over what we thought worked well and give suggestions on what we think can be improved upon moving forward. And we would have been able to discuss also what stories that we think would be most practical to incorporate into our next sprint moving forward. Overall, it would have allowed for better communication and higher levels of transparency about the current status of our progress, thus being more beneficial to our team and overall.
So next we're going to be looking at some more reflections that we kind of thought about throughout the semester and mostly aggregated towards the end of the semester here. And the first thing that we noticed was, as we mentioned a little while before, part of our Scrum application is we implemented, instead of daily stand-ups, we had 3 stand-ups a week where we met in person. And we realized that that didn't really work super well for our team, and it kind of left us not super clear on what each person was working on at a time. And we ended up a couple of times had a couple of developers working on the same thing, so it's kind of duplicated effort for the same task, which wasn't super helpful. And so we believe that if we implemented daily online stand-ups using our Discord channel, which we already communicate with frequently, providing status updates every day would allow us to be much more visible to each other as a team on what we're working on and the progress that we're making on each story during every sprint. And the next thing that we want to reflect on is our implementation of testing. And so the big part is that we didn't begin to look into testing early enough in our project. And like Agile frameworks say that you need to be testing early from the beginning, and you need to be continuously testing throughout a project in order to ensure that the project has the best quality possible. And we realized a little late that we hadn't really started testing and hadn't really implemented testing on both our front end and back end aspects of it. And so it's something that we want to be focusing on, and we've started focusing on these past few weeks. Another problem that we had, mostly starting off in the beginning, was that we had difficulties working with some new tools. You saw a list of the tools that we had worked on. One of them was Node.js, and none of us had been familiar with Node.js, but we knew that Node.js was a really great tool to build APIs, and so that's why we ended up going with it. But none of us had worked with it before, and so that led us to, in the first few weeks, in the first sprint or two, we spent a lot of time trying to understand how to use Node.js and weren't able to make as much progress actually developing code and getting stories done as we wanted to. And alongside that, another problem we had is as we work on different parts of the project, we kind of ended up being in our own silos, where we understood individual parts of the project but not parts of the project as a whole. And so to mitigate that, we wanted to implement some cross-training and documentation about our individual processes so that in the future, any developer can pick up on any of the work that anyone else has been doing. That'll make us more efficient. Another blocker that we had during this semester here is we had some problems integrating with hardware. So a big part of our project, one of the three main parts of it, is the integration with devices such as a robotic fish or RC car or a drone. And we had some issues where there were conflicting shield modules on our Arduino, and that kind of halted our progress towards that. And we had to focus on working on the other two parts, which were our back end and our front end. And so hopefully in the summer we can get those issues addressed moving forward, so we can keep pushing that part of our project forward as well. And finally, with defect tracking, we use GitHub for our repositories for our front end and back end, our website and our API. But we didn't make use of GitHub issues to track our bugs. Rather, when we noticed that there was a bug, we kind of went in and fixed it. And by not documenting down what the bug was, how long it took for us to fix, that's kind of a lack of metrics that we could have had. And so starting from now and into the summer, we're going to be more implementing some more defect tracking to give us better metrics on how we're doing in terms of that. And so what I've talked about some of the reflections. I'm going to talk about some concrete plans that we're going to be doing kicking off this summer semester. And so to start off in this semester, we're going to be implementing code reviews. And this is going to help with the cross-training so that each person, we're going to go through the entire code base so everybody knows every part of the code. And we're going to be overhauling our testing a lot. It's going to be a much bigger part of each sprint, making sure that we have testing done for every story. And we're also going to be kicking up our front end a bit because our front end had fallen behind our back end in the stories because our stories were too large, and it didn't allow us to correctly work on front end and back end stories independently, and they were kind of merged together. And the result of that was just that the back end kind of got ahead of the front end. But we believe by splitting up our stories, we're going to be able to work on those more in parallel and keep the progress the same for them. And now we give the floor to you guys. If there's any questions about anything you saw or anything you want to know that we may have left out, or anything that you are wondering about our project, feel free to ask away. Yeah.
Data acquisition often deals with time series. Did you look at a time series database? If not, how are you storing time sequential time in relation?
We are storing in our database. We're storing both when the device records in our Postgres database, our relational database. We're storing both the device's timestamp when it's recording its data, which will be each individual device has its own time clock, which will be used to store its data. And also on our API, we're storing exactly when that data is created and when it's updated, and also if it's deleted, because we want to have a good history of when things are time-stamped. Does that answer your question?
How do you query for time?
We have part of some of the next upcoming sprints we're going to be working on is filtering and querying by data. And we can query by time being greater than or less than whatever time constraints you want to put in. We haven't gone into performance testing on the performance of how that would be, as it's not something that's high priority for us. It was something that our sponsor, I believe, ranked as low priority, being able to filter things by time. So it's not one of the things that we focused on at this point.